Hello. In this video, I will address how revenue will change when price changes, except when the PED is unit elastic, of course. When you look at this graph right over here, it shows the quantity demanded and the price on a price quantity demanded graph, where I have two quantity demanded functions of Samsung phones. This represents how quantity demanded will change in the same graph for example, merchandise like Samsung. Just imagine in this issue that we only have Samsung versus iPhone. Um, in this problem, I will only account for only iPhones and Samsung, as you see here, as I explained earlier. In this problem, I will start on point O, where the quantity is high, as you see here, as at quantity 1, and the price is low. If Samsung would look at this graph, they would of course raise the price to come closer where the PED is 1 over here. This is the place where is the highest possible revenue and where the income is highest. Anyway, say Samsung raises their price up to point A, where we have a PED value of 1. Samsung revenue is now increasing, which I will prove over here. As I see here, the price 1 over here goes up to price 2, which moves the quantity demanded 1 here to the quantity demanded 2. No matter what I do over here, if I rather choose to have the price on O or that I choose to have the price on A, my revenue boxes B, D, and E will stay the same. I can choose between D or AC, but since I've obviously gone up from O to A by increasing the price, I got A and C, which is now my revenue boxes. So these are all my revenue boxes, and I can see clearly that A and C is bigger than D. This means that the revenue increases. So now it's going great for Samsung, where they have a high revenue at the right amount of price. Then inevitably iPhone comes out with a new phone that makes a lot of the Samsung buyers rather buy an iPhone instead of a Samsung. This will make the graph shift over to the left, where Samsung loses a big amount of their customers. But they will have some faithful Samsung buyers left, so they end up at point B. So, hence, the revenue increases drastically, which is shown over here. As we can see, the P2 stays the same, this line, but it shifts from the quantity QD2 to the QD3, which is from A to B. Here you can see that from A to B, you loses these revenue boxes. The revenue boxes, like at point A, you had the revenue boxes A plus C plus B plus D plus E. While at B, you only have the A and B available, where you lose all those on this side. Samsung will then lower their price back to price 1, so they can gain new revenue boxes because they want it to be closest to where the PED is 1, which is at the point C. Here they gain D, which is bigger than A, so they get B and D, which is a bigger amount of revenue than they had at point B before. This whole situation deals with a term called splat. They don't deal with all of them, where the S is substitute, P is proportional of income, luxury and necessity, addiction, and time to adjust. This problem does not deal with all of those, but it most certainly deals with the term of substitute, where, for example, an iPhone can be a substitute for Samsung. And it kind of deals with the term of time to adjust, where when the new iPhone comes out, you don't just throw away your Samsung and buy the new iPhone, but it's a time where you might want to buy a new phone or you're in the market again for that sort of situation. Okay, that was it. Thank you so much.